was thinking recently about the many times that I've been in a science lab with, for instance, Year 9 students. And Year 9 students have a very healthy disrespect for their own lives and the lives of others. So more often than not, what you'll have in a science lab is that you'll have something like an experiment going on. Let's say it's based on a Bunsen burner. So you've got many Bunsen burners happening. You might have 8 stations, 10 stations, 12 stations, depending on what sort of lab. But you've got quite a few of these experiments going on at the same time. And all the gas comes from some sort of central place. And then the switching is local. So you've got on-off locally. And also you've got usually a complicated system. Maybe it's a key or something like that. And then there's also a big old red panic button. So I was wondering about that, because practically what happens is that often the teacher will be, let's say, dealing with a student over here, and then notice that this one over here has decided that burning something is a lot more exciting than the actual experiment. So there might be a small fire going on here. Now the teacher could rush back to this. They could yell, they could do all sorts of things. But wouldn't it be nice if there was a panic button at all of these stations that a teacher and or student could hit, such that the whole system shut down and then had to be reset via, let's say, the key. So just looking at the CD4001 recently and looking at circuits that we could use. I mean, we had one very recently, and that was to do with the indicating lights on a car. So I'll link that up there, and that used the CD4001, which is a quad 2 input NOR gate logic chip. But whilst looking at different circuits, I came across the old SR latch, the whole idea of setting and resetting. And I was initially looking at it actually in terms of a bounceless button scenario, so that, for instance, if you were turning something off, that it didn't bounce. But the SR latch does that anyway. So as soon as it detects the signal, it doesn't matter if it bounces after that, it latches it one way or the other. So I'm going to just have a bit of a fiddle around on the simulator and see if we can't come up with something which uses the CD4001 to latch the system here, but then be able to delatch the entire system from anywhere in the laboratory. Let's take a look at that. All right, let's power the system on. And then what we've got is essentially a bit of a safety switch that says, okay, we're good to go, which we are now. And then we've got two choices. We've got enable or panic. So I'm going to enable the system, and that means that there's a green light on there, and that just says that any student in the room can actually begin the experiment. So they turn on their Bunsen burner or water tap or electrical supply or whatever it happens to be, and they're good to go. Now, two scenarios. One is, as a teacher, you're by the desk and you notice that at the other end of the room, 5-6 meters away, there's something that's going wrong and you'd like to shut everything down. You hit the panic button and everything is shut down. So the Bunsen burner now, doesn't matter whether that's working or not working, the button is on or off, nothing happens. Okay, so that's fine. And then the other scenario, let's get the system up and live again, is that as the teacher's moving around, and there might be 8 stations or 10 stations that are working, there's a problem on the other side of the room. You're a long way away from your panic button, but you are close to a student button. So you click that and everything shuts down. The students' experiment shut down, and then also the everyone else's experiment shuts down as well. And I've only got one student Bunsen burner going here, so let's duplicate the system and see how that might work with 2 or even 3 Bunsen burners going simultaneously. All right, not sure how much of this you'll be able to see, but let's give it a try. So I've just expanded the same system with the teacher side on the left-hand side and the student side on the right-hand side. So I've got 3 Bunsen burners now. and we'll just start the turn the power on, and we're good to go. And then we will release the safety and start the system. So you should see the green light for the teacher's light come on, and then the various students will start their Bunsen's. So we've got 3 Bunsen's going now. So one scenario is that, let's say we're at the bottom station here, but we notice that at the top there's a problem. So we just hit the switch that's closest, and the whole system shuts down. Perfect. And then we will start it again. There we go. And let's go up to the top here, and we'll shut that one down. And the whole system, shuts down. And of course, there's still the teacher one too, so let's do that while we're here. So all Bunsen's lit, and the teacher hits the panic button, and everything shuts down. All right, let's build it and see if it works. So the simulator circuit certainly looks promising. So what we might now do is build it. Here is the CD4001 left over from the indicator project, and here is another one. So they're the 8 gates that we'll need to build this. Might have the on-off switch for the whole shebang over here, the enable switch, and your panic button. And then we might also have maybe one of our Bunsen's here, one here, and one down here. So that should work pretty well. To simulate the Bunsen, we could use these are great, these little orange flicker. They've got a chip inside them. And I don't know if you can see that. I'll turn off some lights so you can see that pretty well. Yeah, let's turn off some more lights so you can see that pretty well. Let's turn off this guy. Yeah, I hope you can see that. So that's little LFSR inside that, and it's pretty good. So, and what you can do also is you can link up another one in series with that, and of course it'll take its power from the flickering one, and suddenly you've got 2 flickering ones for the price of one. So that's pretty cool. I might do that. So that will be the, let's get some light back on the subject again. So that will be the scenario. Now I don't know if I'll actually do it in terms of a time-lapse build or not. It's pretty boring. So what I might do is actually build up a fair bit of it and come back to the last little bit. Okay, so we have power to the system, and now we're just going to say, right, we're ready to do an experiment. So that's the on-off button done, and then we enable it. So what we've got is the system is now live, and we can disable it or enable it with those buttons there. And we can, of course, disable it with the switch as well. So all good. Next thing to do is to start the experiment. So we get station 1 going, station 2 going. That's an awkward one to get to. Let me get my tweezers out here. There we go. And station 3, I'll do the same. All right, very good. So all of our stations are going, and the experiment's going fine. And I'm at this end of the room, and I notice that there's a problem, so I just hit the kill switch, and everything shuts down. And that's pretty normal. That's not an unexpected situation. However, if I was, let's say, around this station here and noticed that there was a problem at this end, what I could do is just simply flick this switch, and that shuts down the whole system. And again, has to be enabled from just the one here, or this one could be switched, or indeed this one could be switched. So that's just about having multiple kill switches all over the room, so that the time between noticing a problem and shutting the system down is at its lowest. So yeah, I would say that is the circuit working for this week. A complicated build, probably well worth putting this on a PCB if you wanted to take it too much further. Had a few issues with things like randomly bumping it when I was putting in the various wires around the place, but apart from that, not too bad. I'll take some photos so you can see how well it matches up with the simulator. Not a bad build. See you next time.